Hello, my name is Price. Today we're going to compute the determinant of the 4x4 matrix that we have on the screen right here using the Summers computer-aided mathematics program. So, whenever we're trying to compute a determinant using this program, we should turn on determinant mode. This gives us a useful scalar box that will be useful in the computations that we will perform in trying to compute the determinant. When you're given a determinant problem, the technique of cofactor expansion is our friend, because it allows us to simplify the process immensely. What we're trying to do is we're trying to create a column or a row with only one non-zero element in it. The reason we can use either a row or a column is because the determinant of the transposition of a matrix is equal to the determinant of the matrix itself. So all of the rules associated with the definition of the determinant apply to both elementary column operations and elementary row operations. So we want to search for a row that almost has 3 zeros in it, such as row 3. It has 1, 2 zeros in it. So we want to create one more zero. We can do that by adding these two rows together. How about we try to make this -1 go into a 0. So we click on we choose the column that we'd like to mutate, which is column 2, by clicking on the column 2 button, and then we'd like to add column 3 to it. So we go down here and we press the plus operation button, see, and then we're trying to add column 3 to it. So we click on column 3. So now we're trying to set column 2 to column 2 plus column 3. Once we're done figuring out what we want to do, we click on the evaluate button or press E. So column 2 is gone to column 2 plus column 3. So now we can perform a cofactor expansion by row 3. So we select row 3, and then we select the cofactor button to perform the expansion. So now it's created the minors, such as this one, which is the minor with row 3 column 0. Row 3 column 0, that's this one, which is equal to 0. See, there's that 0 there, times this matrix right here. 0, 7, 4, 0, 7, 4, 2, 10, 3, 2, 10, 3, 8, 1, 1, 8, 1, 1. And then it gets multiplied by -1 or plus according to the checkerboard rule. So we go plus, minus, plus, minus. So this would be a negative except it's 0. So since this is multiplied by 0, we can ignore this matrix. So we want to go to the minor that has a non-trivial scalar factor, which would be this one, minor 3, 3. See? If we go back up to the top, the minor row 3 column 3 has a 1, and then this will be the matrix we see down there. And it's positive 1 because plus, minus, plus, minus, plus, minus, plus. So now we've reduced this determinant problem to the following one, which is a more simpler problem. So now we're going to try to do it again. We're going to try to transform this 8 into another 0. So we're going to go to row 2, which is the one we want to modify, and then we're going to subtract. We're going to create a new scalar. Click here, type in 4, because 4 times 2 in row 1 is going to be be just right to subtract from 8 to create a 0. So we click on row 1, and then once we're done, we evaluate it. So now there's 2 zeros inside this column. So let's cofactor again. So we go column 1, and we cofactor. Remember, we clicked on the cofactor button. So now we've got 3, and only one of these minors is non-trivial, so we don't have to worry about the other ones, since the other ones are now equal to 0. So now we've reduced this problem to a 2 by 2. With the scalar 2. See, if we go back here, that 2 is the scalar, and then the minor is 1, negative 39, 7, 6, negative 6. See, there's that 1, there's that 7, there's the negative 31, 39. So we could either apply directly the definition of a 2 by 2 by 1 negative 39 minus negative 6 times 7 times 2 to get the answer. So first of all, let's make it easier to see what we're doing. So let's multiply 2 times 1 times negative 39 minus negative 6 times 7. And we evaluate, and the answer is 6. So let's try finding this a different way. Well, first of all, congratulations, we found the answer is 6. I like that, but let's branch right again to try that again. How about we continue with the cofactoring plan? So let's make a 0 here from this negative 6. So we click on the row we want to mutate, row 1, and then we'd like to add, to create a new scalar, and we're going to type in 6, because 6 times 1 will be enough to, 6 plus negative 6 will be 0, and that's what we want. So we click on row 0, like that, see? Now we're going to add them together, and they're going to create a 0. So once we're done, we click on the evaluate button. Now we've evaluated. So now we can either cofactor expand by row 1 or column 0. Let's choose row 1. Row 1, and then with the cofactor expand, we click on cofactor. And now it creates 2 minors, it's now created two minors, one of which is trivial, and the other is right here. And so the answer is 6. Let's go back to make sure that this is the same as the one we used to have. So down there, the answer is 6 as well. See? So using the same logic, we got 6. 1 times 6 is 6. So either way, even if we keep on going, we'll still get to 6. There's many ways to compute the determinant. We just need to remember to do every step correctly. Thank you for listening. Goodbye.